Welcome back to another tutorial on trusses. Let's solve this truss using the method of joints. The first thing we want to do is check if we can actually solve it. Let's check if this truss is determinate. Let's start off by drawing a free body diagram. That means that we are going to replace our supports with the reaction forces. So here on this side we have a pin support. Just going to rub that out and draw in its place two reaction forces. And I'm going to rub out this roller support as well and draw in that one reaction force for the roller support. Okay. Now that we have our free body diagram, let's check if this truss is determinate. So we'll start off by figuring out what we do not know. So what are our unknowns? So we don't know the reaction forces. In this case, we have 3, right? And we do not know the internal forces in the members. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 members. So together, that gives us the number of unknowns as 12. On the other hand, we do know that at every single joint, we can write 2 equations of equilibrium. So that means the number of knowns is 2 times the number of joints, which in our case is 2 times 6 joints, and that gives us 12. In this case, the number of knowns and the number of unknowns are equal, so this truss is determinate. And we can solve it using the method of joints. So this truss is determinate, and we can solve it using the method of joints. Before we start solving, let's number the joints and declare our sign convention. So, numbering the joints, I'm going to go with 1, 2, 3, 4, 5, and 6. And as for sign convention, I am going to use the right-hand rule, which means that my positive x, my positive y, and my positive moments are in these directions. Okay, so right hand rule. Now that we've established that, let's move on to finding the reactions. In order to do that, I am going to label these reactions. Here I had a pin joint, and I'm going to label this V vertical 1 and H1 for horizontal 1, and here I'm going to call this V4, the vertical force at joint 4. And that's it, we're ready to find reactions. Let's start here with the horizontal direction. So sum of forces in the x direction equals 0, and just a reminder that this is my positive x direction. So I've got H1 in the positive x direction, and I've got that external load of 4 kilonewtons at joint 5 also in the positive x, so plus 4 equals 0, and H1 therefore works out as minus 4 kilonewtons. And I'm just going to highlight that quickly so that I can easily find it later when I need to. The next thing I'm going to do is I'm going to do the sum of moments, and I'm going to do them around joint 1, okay, with a reminder that this is my positive direction. The reason I'm doing it at joint 1 is because V1 and H1, those 2 reaction forces, pass through joint 1, meaning they will not contribute moment. I'll have all the external loads contributing to moment and V4 also contributing to moment. This will allow me to find V4. Okay, so let's start off. Let's start off with this 6 kilonewton force. Okay, we can see that it is contributing a clockwise moment, which is negative in our sign convention, and the perpendicular distance from the line of action for that 6 kilonewtons until joint 1 is 4 meters. So minus 6 times 4. The 3 kilonewtons at joint 3 also contributes a negative moment, and this time the distance is 8. On that same line, I also have V4. V4 contributes a positive moment, and the distance here is 12. Now I can't forget the 4 kilonewtons at joint 5. Okay, it is also contributing a negative or a clockwise rotation. So -4, the perpendicular distance between the line of action of 4 and joint 1 is 3 meters. Let's work our way through this. So -6 times 4, that is -24. -3 times 8, also 24. So another -24. Plus 12 V4 and -12 equals 0. Let's isolate the V4. So I've got 12 V4. Since isolating the V4 gives me negative and negative on the other side, I can multiply by +1 and it'll be positives on both sides. And here I have 24 plus 24 plus 12, which gives me 60. 60 divided by 12 is 5, and therefore V4 works out as 5 kilonewtons. Okay, let's highlight that as well. And now the easiest thing to do is sum of forces in the y direction equals 0. This is my positive y. So in this case, I've got V1 plus V4 minus 6 and -3 equals 0. So V1 equals 9 minus V4. So that is 9 minus 5. And I end up with V1 equals 4 kilonewtons. So now that I know all of these reaction forces, I can replace them in my graphical drawing. So we said that V4 was 5 kilonewtons. V1 worked out as +4, so meaning we assumed the right direction, so 4 kilonewtons. And H1 was -4. This means that the direction that we assumed is incorrect. It's really facing the other direction. So what we need to do is just replace this with an arrow going the other way and with a value of 4 kilonewtons. And that's it. Now that we've found the reactions, we can move on to solving the truss using the method of joints. Before we start solving, let's quickly remind ourselves of what the method of joint entails. What we do is we separate each joint from the members, draw the internal forces, and look at each joint as a system of concurrent forces at the joint. Okay? So looking here at the truss that we have, okay, we can see here in purple, I've drawn out all those forces that we need to find, so all those internal forces representing the members. I have in red the external forces that were given as part of the truss, and in blue I have the reaction forces that we just found. I know that in each joint I can only write 2 equations of equilibrium. So in each joint, essentially, I can only solve 2 unknowns. I will have to, therefore, start off at a joint with only 2 unknowns. If I look here, quite a lot of the joints have much more than that. So, for example, 5, 6, 2 and 3 have much more than just 2 unknowns. I can see here that both joint 1 and joint 4 have 2 unknowns, and I could start with either of them. Once I found the members from joint 1 or 4, depending where I start, I will start essentially finding the forces from different joints, and therefore they will also become at some point with only 2 unknowns, and I'll be able to solve them. So let's begin with joint 1. So let's start with joint 1. Looking at joint 1, I've got these 2 unknown forces, force 1, 2 and 1, 5, and I've got these 2 reaction forces of 4. Let's start off by solving the sum of forces in the y direction, because in the y direction I only have a component of F15, so only one unknown. So sum of forces in the y direction equals 0. This is my positive direction. So I've got F15 positive sine alpha, and I've also got 4 that reaction force. Nothing else, so that equals 0. And F15 equals minus 4 sine alpha. You can find alpha through trig and find it that way, or you also know that sine alpha is also 3 over 5, and this gives me minus 20 over 3, which we can also write out as minus 6.67 kilonewtons. Okay, and just highlighting that so I can find it later. I can now move on to do the sum of forces in the x direction equals 0, and now I have F12 in the positive x minus 4, that reaction force, and plus F15 cos alpha equals 0. So F12, which is what I'm looking for, equals 4 minus F15 cos alpha. F15 I already know, right, because I found it. It is minus 6.67 times cos alpha, which is 4 over 5, equals 0. And just one thing to highlight here, I only substitute the values after I've reached the last equation. Otherwise, it is so easy to get mixed up with the minus and plus signs. Okay, so now I know that F12 is 4 plus 6.67 times 4 over 5, and that gives me 9.33 kilonewtons. And what I like to do already at this stage is just write out those results on the truss. It helps me check what I've already found and also helps me check the values for the end. Okay, so 19 we said is minus 6.67 and F12 is 9.33. I can now move on to joint 4 because they're two unknowns, I already established that, or I can move on to joint 2 because joint 2 before had 3 unknowns. However, now that I've solved F12, there are only 2 unknowns at joint 2. Let's go with joint 2. So first thing, let's draw the joint. So we've got here joint 2, our 2 forces that we need to find, F34 and F46. Okay, we've got our alpha here, and we've also got a reaction force of 5 kilonewtons going up. All right, let's start with the sum of forces in the y direction because only the component of F45 is in the y direction and the reaction force, so only one unknown. So forces in the y direction equals 0. So we've got F46 sine alpha plus 5 equals 0. So F46 equals minus 5 divided by sine alpha, which gives us minus 5 divided by 3 over 5, and that gives us minus 25 over 3 kilonewtons. Okay, you can also write it out as minus 8.33 kilonewtons. Okay, and just highlight that so we can find it. If we do the sum of forces now in the x direction, with this being the positive x, we've got minus F34 because that's in the negative x direction, and we've also got minus F46 cos alpha, nothing else in the x direction, so that equals 0, and F34 equals minus F46 cos alpha, so that is minus 8.33 3, 3 times 4 over 5, and that gives us plus 6.67 kilonewtons. So highlight that and let's put them on our drawing. So F46 minus 8.33 and 34 6.67. Let's quickly have a look at where we are now with solving the truss. Okay, we've so far solved 2 joints and we still have a number of members left to find. Okay, so if we look at this, joint 5 still has 3 unknown members, joint 6 has 2 unknown members, and joint 3 has 3 unknown members, and joint 2 has 2 unknown members. So you could really either solve joint 2 or joint 6. Let's start off with joint 2. So joint 2, we've got F2, 3, we've got F2, 5, we've got F1, 2, and we've got this external load of 6 kilonewtons. Now nicely, everything is at right angles, so we don't have any angles to find here, which is good. Okay, can start either in X or Y. Let's start off with the Y direction. So sum of forces in Y, this being my positive direction, equals 0. So I've got F25 in the positive Y direction minus 6 in the negative Y direction equals 0. So F25 equals 6 kilonewtons. Okay, and let's highlight that quickly. The next thing that I want to do is the sum of forces in the X direction equals 0, with this being my positive X direction. So I've got F23 minus F12 equals 0. I do actually know what F12 is, but let's start off by isolating F23. So that will be positive F12, and that means from my drawing I can see that F23 is 9.33 kilonewtons. Okay, a quick highlight here, and let's put it on our drawing because that is very helpful. So got 9.33 here, and I've also got F25, which is 6 kilonewtons here. And now really I can go to any joint that I want. So now that I've solved this, joint 5 only has 2 unknowns and joint 6 also has only 2 unknowns. Let's go to joint 6. Okay, let's draw all the forces at joint 6. So at joint 6, I have a force of F46, I've got a force of F36, and I've got a force of F56. No external forces in this joint, and that is alpha here. Let us start off with the sum of forces in the X direction. So here I've got F46 in the positive X, cos alpha minus F56 equals 0. And I do know what F46 is, which makes it easy to find F56. So F56 equals plus F46 cos alpha, and F46 I already know is minus 8.33, and cos alpha is 4 over 5, and so F56 works out as minus 6.67 kilonewtons. Let's also do sum of forces in the Y direction equals 0. In the Y direction, I've got minus F36, and I've also got minus 4/6 sine alpha. So f(3/6) is minus f(4/6) sine alpha, and that is minus 8.33, and sine alpha is 3/5, and that gives me plus 5 kilonewtons. Let's write them onto our graph. So 5/6 is minus 6.67, and 3/6 is 5. We can see here that we now only have one member that we don't know, which is member 3/5. We can either go to joint 3 or we can go to joint 5. Let's go to joint 3 and see what's happening there. So at joint 3, we have f(3/4), we have f(2/3), we have f(3/6), we also have f(3/5), and we have an external force of 3 kilonewtons, and this is angle alpha here. Let's start off with the sum of forces in the x direction and try not to miss anything, right? This is my positive x. Let's see what I've got in the x direction. I have got f(3/4) in the positive x, I've got f(2/3) in the negative x, and I've also got a component of f(3/5) in the negative x, and this time it is cos alpha. And that is all I have in x, so those three equal 0. So f(3/5), if I isolate it, it's going to equal to f(3/4) minus f(2/3) divided by cos alpha. f(3/4), I know what that is 6.67, and f(2/3) is 9.33, so minus 9.33, and all that divided by cos alpha, which is 4/5, and that gives me minus 3.33 kilonewtons. So I can highlight that here. And that really is the only thing that we were missing. So at this point, I have found all of the members of the truss. We can see them here in this graphic. So now that we've found everything, anything that we do from this point on is a check. It is always good to check the forces that you get in a truss. It can allow you to find any mistakes and rectify them quickly. Let's start off by checking the y direction at this joint. So the sum of forces in y equals 0, and let's check that they do. So what do I have? I have f(3/6) going in the positive y. I also have a component of f(3/5), this time sine alpha in the positive y, and I've got that external load of 3 kilonewton in the negative direction. That equals 0. Let's check. So f(3/6) was 5. f(3/5) we just found, that is minus 3.33 times sine alpha, which is 3/5, and minus 3. Let's hope this works out. So what do we have? We've got 5, this is minus 2, and this is minus 3, equals 0. Does it? It does indeed. So that first check gives us a good indicator that we've solved the members in this truss correctly. Let's not stop there. Let's do some more checks. Let's check what's happening at joint 5. We haven't had to touch joint 5 until this moment, right? We've solved all the forces without reaching it, but let's see what happens there. and let's, fingers crossed, everything equals 0. Let's do it. So at joint 5, we've got a force of F5, 6. We've got a force of F3, 5. We've got F2, 5. We've got F1, 5. And we've also got an external force of 4 kilonewtons in this direction. Okay. Alpha is this angle here and also this angle here. Let's start off by checking the sum of forces in the y direction. So in the y direction, we have negative F2, 5. We've got negative F3, 5 sine alpha. And we've got negative F1, 5 sine alpha. Everything else is not in the y direction. So let's have a look at this. F2, 5 was 6. So we've got here minus 6. F3, 5 was minus 3.33 sine alpha. And F1, 5 was minus 6.67 times sine alpha, and that all equals 0. So we've got here minus 6 plus 2 and plus 4 equals 0. Indeed, that works out as 0. So another good indication that my calculations are correct. We can also check the sum of forces in the x direction. And here we have 4 plus F5, 6 plus F3, 5 cos alpha and minus F1, 5 cos alpha equals 0. So quite a lot of components here. And that gives me 4 plus minus 6.67 plus minus 3.33 times cos alpha, which is 4 over 5, and minus 6.67 cos, which is another 4 over 5 equals 0. And that works out as 4 minus 6.67 minus 2.66 and plus 5.33 equals 0. And I end up here, if I sum that up, with 9.33 plus and another minus 9.33 equals 0, and does indeed equal 0, which means that I have solved this truss correctly. So just remember, it's important to maintain those signs, and it's also important to check your trusses. I hope you've enjoyed this, and if you have, please join me again where we solve some more trusses using the method of joints. Bye for now.